Example 185. Use the sign test to test the claim that the median is less than 98.6 degrees Fahrenheit. There are 68 subjects with temperatures below 98.6, 23 subjects with temperatures above 98.6, and 15 subjects with temperatures equal to 98.6. Okay, so we're using the sign test, but when we do the sign test normally, we use the binomial table to calculate a p-value. The problem with this example is that there are too many subjects involved in the study, and so with all those subjects, we won't be able to use the binomial table. When this happens, we're going to use the large sample approximation. So essentially, we're going to use the normal distribution as an approximation to the binomial distribution. So the first thing we want to do then is to express the claim in the problem. The claim is expressed pretty clearly in that first sentence. Is use the sign test to test the claim that the median, so that's the median, is less than 98.6. 98.6 degrees Fahrenheit. Okay, so there's your claim. HO, HA then follow from that. The claim has a less than symbol. That means it's the same as HA. And HO, of course, has the opposite idea. It'll be greater than or equal to 98.6 degrees. All right, so now that you have the claim HOHA, your next step is to work with the data a little bit. And all we're going to do here is calculate a special quantity. We need to do two things. We need to throw out any ties. So any tie that's equal to 98.6, any body temperature that was actually equal to that value should be ignored in the problem. So we see there were 15 subjects with temperatures equal to 98.6. We're going to discard those. So we're going to say, okay, first of all, the n for the problem, if you look at it, is what? 68 plus 23. So it's a total of 91 total values, right? So if you add 68 and 23 together, you get 91, and that gives you the n. You do not include these 15 subjects because they had a temperature that was tied with the value you see in HO, so remember we throw out ties. So we're only going to look at n being 91. The next thing you're going to do is calculate something called S minimum. S minimum is the of the remaining two categories that are left after discarding the ties. We're going to look for the one that has the smallest number of subjects as a part of it. So there are 68 subjects with temperatures below 98.6. There were 23 subjects with temperatures above that. So we're going to use 23 as S minimum. S minimum just means the smaller of those two other categories. Okay, so now that you have those two things accomplished, your next step then is to fill out the test stat. Now the test stat here is actually a z value because remember we're using the normal distribution as an approximation to the binomial distribution in this problem. And the formula is a little bit interesting. It has S minimum, the value we just came up with, plus 0.5, so 0.5. You'll remember that the plus 0.5 is something we do to do continuity correction when we're actually using the normal distribution as an approximation to the binomial distribution. So if you look back at that section where we did the approximation technique, you'll see we used either plus 0.5 or minus 0.5 depending on what scenario we were working with. In this problem, the test stat is set up so we always use plus 0.5. And then we're going to subtract off the mean, which would be n over 2 in this case. This comes from the fact that it's a binomial distribution with a 50% probability or 1/2 probability of success, right? And then the standard deviation as a result of that same property comes out to be the square root of n over 2. If you look back at the formulas for binomial probabilities, mean and standard deviation, you'll understand why these values are what they are. But either way, it doesn't matter if you understand it, that's the formula. So from there, we can plug in these numbers then. S min is 23. It'll be 23 plus 0.5, so I'll just say 23.5 minus the n, which is 91 over 2. And then divided by the square root of 91 over 2. So that's going to be your test stat formula, right? Okay, so let's do that quickly. We'll say 23.5 minus 91 divided by 2. And when you're done, you get negative 22 on top. And then from there, you'll be dividing by the square root of 91 divided by 2. And you'll get 4.769, etc. So 4.769 dot, dot, dot. And then if we divide those two, we'll come up with our overall answer. So we're going to have minus 22 divided by the value that we see there. We end up with negative 4.61. Negative 4.61. I'm going to say this is approximately negative 4.61. All right, so now that we have our test stat, we're going to take that test stat and compare it against a critical value. So let's think about this particular test. It's a left-tailed hypothesis test, right? And because of that, we're going to draw a bell curve, indicating a left tail on the curve. And then from there, what you're going to do is just say, okay, this is a z-axis, and the alpha is not stated in the problem, so we'll assume it's 5%. So we're going to assume that's 0.05. Remember, 5% is the default case. So we're going to look at that and say, okay, based on the location here, being on the left-hand side, it'll be negative. But based on the location here with 5% area and one tail, what is our critical z value? Remember how we do this. We go to the z table or the t table. In this case, we're going to use the t table because this is one of the values we have on the t table. We're going to look up 0.05 and one tail, and we'll go straight to the bottom where the z-scores are located. Let's go do that now and see what we come up with. Okay, so we're at our t table. We're looking up 0.05 and one tail. We have to go straight to the bottom where we'll find the z values at the very bottom of the table. And when we do that, we find the answer to be 1.645. Of course, since it's on the left-hand side, it'll be negative 1.645. Okay, so after looking up the number on our 0.05 on the t table, we get negative 1.645. All right, so that's our critical value, and we're going to compare that critical value to our test stat, and you can see this test stat is quite extreme. It is going to definitely land inside the rejection region. So with that, we're going to conclude then that we should reject HO, and therefore support HA. And with that in mind, what we're going to do is look at the claim and say, hey, look, the claim is the same as HA, so we should support the claim. And then what we're supporting is the idea that the median is below 98.6. So the median body temperature appears to be below 98.6. And that's it.